Action potentials trigger the contraction of skeletal muscles. These impulses travel through the neuron in order to reach the skeletal muscle at the neuromuscular junction. When the action potential reaches the axon terminal at the junction, acetylcholine vesicles release the acetylcholine they contain, which then diffuses throughout the synapse cleft, binding to acetylcholine receptors. These receptors are the home to cation channels, which open due to the acetylcholine activation. Depolarization begins when the sodium and potassium channels open and allow the entry of Na+ ions and the departure of K+ ions. A greater influx of Na+ ions causes the membrane potential to become more positive. This movement of ions causes the membrane potential to rise from its resting state of -70 to the threshold of -55. As soon as the membrane potential reaches this threshold, the action potential spreads throughout the sarcolemma. The action ceases when either acetylcholine diffuses off of the cleft or the enzyme acetylcholine esterase breaks the acetylcholine down into acetic acid and choline. The choline is then transported back into the axon terminal to be resynthesized back into acetylcholine. Na+/K+ pumps then open, returning Na+ ions back out and K+ ions back in, slowly returning the membrane potential back to its original state of more negative in what is known in the repolarization period. After the repolarization period of the membrane, the refractory period occurs. This is when no new action potential can happen until the process starts all over again.